Namaste, students. I'm Dr. Amita Kapoor. Have you ever looked up at the stars or watched a cricket ball fly through the air and just wondered, how does it all work? Well, believe it or not, there's a secret language that describes all of this motion perfectly. It's the language of mathematics. And today, we're going to learn how to speak it. So let's kick things off with this really powerful idea. See, in physics, an equation, it's not just some boring math problem you have to solve. No. Think of it like a story, or maybe even a secret code. A code that, once you crack it, tells you exactly how nature behaves. And that's our mission for today, to start cracking that code. This quest to understand the universe through math, it's not new at all. In fact, for us, it's a part of a long, and very proud tradition. We're talking millennia ago when our own rishis and scholars were gazing at the very same sky, asking the very same questions, and using mathematics to find the answers. Think about it. For centuries, you had these absolutely brilliant minds right here in India. People like Aryabhatta, Bhaskara. They were the original decoders. They used the beautiful precision of mathematics to map the heavens. They wrote equations that describe the motion of planets and stars. And what we're doing today? We're walking in their footsteps. We're continuing that very same tradition. Okay, so we've been talking about planets and stars, huge cosmic stuff, right? Well, now let's bring all that incredible thinking right down to Earth, right into our own backyard, actually. Because the very same rules that guide the planets, they can also tell us the story of something as simple as throwing a ball. Just picture it in your mind. You throw a ball, it shoots up from your hand, gets higher and higher, and then for just a split second, it seems to hang there in the air, right? Before it makes this beautiful, graceful arc back down to the ground. That journey creates this perfect curve you're looking at. So the question is, how can we capture that entire flight perfectly? Well, here it is. This is the secret code for that perfect arc. The equation is h of t equals negative 4t squared plus 20t. It might look like just a bunch of symbols, but it's so much more. This little line of text can tell us the ball's exact height, that's h, at any given moment in time, that's t. Every single point on that beautiful curve is locked away inside this one equation. This is so important. A physicist's job isn't just to, plug in numbers and get an answer. Anyone can do that. Our job, your job, is to read the equation, to interpret it. We have to treat it like a sentence in a story and figure out what it's telling us about the ball's incredible journey. So what are the big moments in this story? The highlights, you could say. When does the journey begin? When does the ball finally land? And what about the climax? How high does it actually go? Guess what? Our equation holds all the answers, and it's just waiting for us to ask the right questions. All right, let's do it. Let's break this flight down into its most important parts. Using our secret code, we're going to find the exact start, the absolute peak, and the final finish. Okay, first things first. A good place to begin is, the ground. So in the language of our equation, we're really asking, at what times is the height, h, exactly 0? And if you think about it, there have to be two moments, right? The moment it leaves the ground and the moment it comes back down. Now, in the world of math, these special values, the times when our height is 0, have a cool name. They're called the roots of the equation. But for us, as physicists, they're not just some numbers. Roots are real. They are specific, important moments in time that we can actually picture. And check this out. We don't even have to do all the heavy lifting ourselves. We can use a simple computer program as our tool. We just feed it the numbers from our equation, the coefficients, and ask it to find the roots. And bam, just like that, it spits out two answers for us, 0 and 5. So what are 0 and 5? They're not just numbers, remember? They're key plot points in our story. Time equals 0 seconds. That's the beginning. The instant the ball is thrown. And time equals 5 seconds. That's the end. The exact moment it hits the ground again. Wow, those two little numbers just told us the entire flight lasted exactly 5 seconds. All right, we've got the start and the finish locked down, but what about that moment of suspense in the middle? That dramatic pause at the very top? Let's find the peak of the journey. What's the absolute highest point the ball reaches? If you look at the graph of the flight, this highest point has a special name. It's called the vertex. And physically, this is that amazing moment we talked about, where the ball just seems to hang in the air. Its upward climb stops. Its speed is 0 for just an instant before gravity takes over and says, all right, time to come down. And guess what? We can pinpoint that exact moment. It's a simple two-step process. First, we use a handy little formula to find out when the peak happens, and the answer is 2.5 seconds. Makes sense, right? Exactly halfway through its 5-second flight. Then, for step 2, we take that time, 2.5 seconds, and we plug it back into our main equation to find out just how high the ball was. And the equation tells us the maximum height is exactly 25 meters. Just think about that for a second. That's not a guess, it's not an estimate, it's a perfect, precise answer that we pulled right out of our mathematical model. How cool is that? Okay, this next part, this is where things get really, really powerful. Because once we have an equation that we know works, a model that we can trust, we can do more than just describe what already happened. We can actually start to predict things. This, this is the true magic of physics. And this is the key takeaway, everyone. You don't need a stopwatch anymore. You can put away the measuring tape. Because our equation, our model, it's like having a superpower. It lets us know the ball's exact height at any moment we want, even if we weren't watching it at that time. So, let's put this superpower to the test, shall we? Let's just pick a random time, a moment we haven't looked at yet. How about 1.5 seconds after the throw? Let's ask our equation, hey, where was the ball at t equals 1.5 seconds? And the process is exactly what you'd think. It's super simple. We just take that number, 1.5, and we pop it into the spot t in our equation. Then we let the math do its thing and tell us the answer. And there it is. The prediction is 21 meters. At exactly 1.5 seconds, the ball is 21 meters up in the air. Think about what we just did. We used mathematics to see something that we couldn't measure with our eyes. We saw the unseen. That is the incredible power we've been talking about. So please remember this. What you did today wasn't just solving a math problem. Not at all. Today, you learned to think like a physicist. You took what looked like a bunch of abstract symbols and you used it to read the real physical story of something moving through our world. So I'll leave you with this final thought to ponder. From the grand cosmic dances mapped out by Aryabhata all the way down to the flight of a cricket ball in your neighborhood, how is it possible? How can this beautiful, elegant language of mathematics give us this almost magical ability to understand, describe, and even predict the secrets of our universe? Thank you.